Hello, guys. Welcome to a new chapter of the book of Michio Kaku, The Future of Humanity. I would like to start, as is tradition here, with a quote from E. Cummings. "Yours is the light by which my spirit's born. You are my sun, my moon, and all my stars." Chapter 2, New Golden Age of Space Travel. Unlike the decline of China's naval fleet, which lasted for centuries, the US manned space program is experiencing a revival after only a few decades of neglect. A variety of factors are turning the tide. One is the influx of resources from Silicon Valley entrepreneurs. A rare combination of private funding and governmental financing is making possible a new generation of rockets. At the same time, the falling cost of space travel allows a range of projects to become feasible. Public support for space travel is also reaching a tipping point, as Americans again warm up to Hollywood movies and TV specials about space exploration. And most importantly, NASA has finally regained its focus. On October 8, 2015, after years of muddle, vacillation and indecision, NASA finally declared its long-term goal, to send astronauts to Mars. NASA even sketched out a rough set of goals for itself, beginning with returning to the moon. Rather than a final destination though, the moon will be a stepping stone for the more ambitious goal of reaching Mars. The once rudderless agency suddenly had a direction. Analysts hailed this decision, concluding that NASA was once again claiming the mantle of leadership in space exploration. So first, let us discuss our nearest celestial neighbor, the moon, and then travel outward into deeper space. The backbone of NASA's effort to return to the moon is a combination of the Space Launch System, Heavy Booster rocket, and the Orion space module. Both of them are orphans of President Obama's budget cut of the early 2010s, when he cancelled the Constellation program. But NASA was able to salvage the space module of the Constellation, the Orion capsule, as well as the SLS Heavy Booster rocket, which was still in the planning stage. Originally from entirely different missions, they were cobbled together to create NASA's basic launch system. Currently, the SLS Orion rocket is scheduled to conduct a manned lunar flyby in the mid-2020s. The first thing you notice about the SLS Orion system is that it does not look like anything in its immediate predecessor, the Space Shuttle. It does, however, resemble the Saturn V rocket. For about 45 years, the Saturn V rocket has been a museum piece, but in some sense it is now being resurrected as the SLS booster rocket. Seeing the SLS Orion brings on a sense of deja vu. The SLS can carry a payload of 130 tons. It is also 322 feet tall, comparable to the Saturn V rocket. The astronauts, instead of sitting in a ship on the side of their booster rocket like they did on the Space Shuttle, are in a capsule perched directly on top of the booster rocket, like the Apollo spacecraft was on the Saturn V. The SLS Orion, unlike the Space Shuttle, is dedicated to carrying mainly astronauts and not cargo. In addition, the SLS Orion is not designed to merely reach near-Earth orbit. Instead, like the Saturn V, it is designed to attain Earth escape velocity. The Orion capsule is designed to carry 4 to 6 crew members, while the Apollo capsule of the Saturn V only held 3. Like the Apollo capsule, the Orion capsule is cramped inside. It is 16 feet in diameter and 11 feet tall and weighs 57,000 pounds. Since space is at a premium, astronauts have historically been small people. Yuri Gagarin, for example, was only 5 feet and 2 inches tall. And unlike the Saturn V rocket, which was specifically designed to go to the moon, the SLS rocket can take you almost anywhere, to the moon, the asteroids, and even Mars. We also have the billionaires who are tired of the lumbering pace of NASA bureaucrats and want to send astronauts to the moon and even Mars relatively soon. These young entrepreneurs were lured by former President Obama's proposal to have private enterprise take over the manned space program. Defenders of NASA claim that its cautious pace is due to NASA's safety concerns. In the wake of the 2 Space Shuttle disasters, congressional hearings almost caused the space program to shut down entirely amid strong public disapproval. Another disaster of that scope could put an end to the program. Also, they point out that in the 1990s, NASA tried adopting the mantra faster, better and cheaper. However, when the Mars observer was lost in 1993 due to a ruptured fuel tank, just as it was about to orbit Mars, many thought that NASA might have rushed the mission, and the faster, better and cheaper slogan was quietly dropped. So one has to strike a delicate balance between the hotheads who want an accelerated pace and the bureaucrats who are gun-shy about safety and the cost of failure. Nevertheless, two billionaires have taken the lead in fast-tracking the space program. Jeff Bezos, founder of Amazon and owner of the Washington Post, and Elon Musk, founder of PayPal, Tesla and SpaceX. The press is already dubbing it the Battle of the Billionaires. Both Bezos and Musk would like to shift humanity into outer space. While Musk is taking the long view and setting his sights on Mars, Bezos has a more immediate vision of going to the moon. People from all over the world have flocked to Florida, hoping to catch a glimpse of the first capsule that will take our astronauts to the moon. The lunar capsule will carry 3 astronauts on a voyage unprecedented in human history, an encounter with another celestial body. The journey to the moon will take about 3 days, and the astronauts will experience things never felt before, such as weightlessness. After a heroic voyage, the ship will splash down safely into the Pacific Ocean, and its passengers will be celebrated as heroes, opening up a chapter new in world history. All the calculations have been done using Newton's laws, ensuring a precise voyage. There is one problem. It's actually a tale written by Jules Verne in his prophetic novel From the Earth to the Moon, published in 1865, just after the end of the Civil War. The organizers of the moonshot are not NASA scientists but members of the Baltimore Gun Club. What is truly remarkable is that Jules Verne, writing more than 100 years before the first lunar landing, was able to predict so many features of the actual moonshot. He was able to correctly portray the size of the capsule, the location of the launch, and the method of landing back on Earth. The only major flaw in his book was the use of a gigantic cannon to send the astronauts to the moon. The sudden acceleration of the gunshot will be about 20,000 times the force of gravity, which will certainly kill anyone aboard the ship. However, before the coming of liquid fuel rockets, Verne had no other way to envision the journey. Verne also postulated that the astronauts would become weightless, but only at one point, midway between the moon and the Earth. He did not realize that the astronauts would become weightless throughout their voyage. Even today, commentators make mistakes about weightlessness, sometimes stating that it is caused by the absence of gravity in space. Actually, there is plenty of gravity in space, enough to whip giant planets like Jupiter around the Sun. The experience of weightlessness is caused by the fact that everything falls at the same rate, so an astronaut inside the spaceship will fall at the same rate as his ship and experience the illusion that gravity has been turned off. Today, it is not the private fortunes of the members of the Baltimore Gun Club fueling this new space race, but the checkbooks of moguls like Jeff Bezos. Instead of waiting for NASA to give him permission to build rockets and a launch pad with taxpayer money, he founded his own company, Blue Origin, and is building them himself with his own pocket money. Already the project has gone beyond the planning stage. Blue Origin has produced its own rocket system, called New Shepard, named after Alan Shepard, the first American to go into space by a suborbital rocket. In fact, the New Shepard rocket was the first suborbital rocket in the world to successfully land back on its original launch pad, just beating out Elon Musk's Falcon rocket, which was the first reusable rocket to actually send a payload into Earth orbit. Bezos' New Shepard rocket is only suborbital, meaning that it cannot reach a speed of 18,000 miles per hour and go into near Earth orbit. It won't take us to the moon, but it may be the first American rocket to routinely offer tourists a view of space. Blue Origin recently released a video of a hypothetical journey on the New Shepard, and it looked like you were riding first class on a luxury ship. When you enter the space capsule, you're immediately impressed with how roomy it is, far from the cramped quarters often seen in science fiction movies. There is ample room for you and 5 other tourists to be strapped into your lush reclining seats, where you immediately sink into black leather. You can look out of huge windows that are approximately 2.4 feet wide and 3.5 feet tall. Every seat is a window seat, the largest windows ever in space, Bezos claims. Space travel has never been so gorgeous. Because you're about to enter outer space, there are some precautions you must take. 2 days before the trip, you fly into Van Horn, Texas, where Blue Origin has its launch facility. There you meet your fellow tourists and hear short talks by the crew. Since the voyage is completely automated, the crew members do not ride along with the tourists. Your instructor explains that the entire trip will take 11 minutes as you soar vertically 62 miles straight up, reaching the boundary between the atmosphere and outer space. Outside, the sky will turn dark purple and then inky black. Once the capsule reaches outer space, you can unbuckle your seat and experience 4 minutes of weightlessness. You will then float like an acrobat free of the earthly constraints of gravity. Some people get sick and vomit while experiencing weightlessness, but this won't be a problem, this doctor claims, since the trip is so short. For training astronauts, NASA employs the Vomit Comet, which is a KC-135 airplane that can simulate weightlessness. The Vomit Comet rises steeply and suddenly shuts off its engines for about 30 seconds, and then falls back down. The astronauts are now like a rock thrown in the air. They are in free fall. When the airplane turns on its engines, the astronauts fall back to the floor. This process is repeated for several hours. At the end of the New Shepard trip, the capsule releases parachutes and then gently lands back on the ground using its own rockets. There is no need for a splashdown in the ocean. And unlike the space shuttle, it has a safety system so that you can be ejected from the rocket if there is a misfire during launch. The Space Shuttle Challenger did not have such an ejection system and 7 astronauts died. Blue Origin has not yet released the price tag for this suborbital trip into space, but analysts think initially it could be in the neighborhood of $200,000 per passenger. This is the price of a trip on a rival suborbital rocket being developed by Richard Branson, another billionaire who has made his mark in the annals of space exploration. Branson is the founder of Virgin Atlantic Airways and Virgin Galactic, and he is backing the efforts of aerospace engineer Burt Rutan. In 2004, Rutan's Spaceship One made headlines when it won the $10 million Ansari X Prize, and it was able to reach the boundary of the atmosphere 70 miles above the Earth. Although Spaceship Two suffered a fatal accident in 2014 when flying above the Mojave Desert, Branson plans to continue testing the rocket and make space tourism a reality. Time will tell which rocket system will succeed commercially, but it seems clear that space tourism is here to stay. Bezos is producing yet another rocket that will send people into Earth orbit. It is the New Glenn rocket, named after astronaut John Glenn, the first American to orbit the Earth. The rocket will have up to 3 stages, stand 313 feet tall, and generate 3.8 million pounds of thrust. Although the New Glenn rocket is still being designed, Bezos has dropped hints that he is planning an even more advanced rocket to be called the New Armstrong, which may go beyond Earth orbit and all the way to the moon. When he was a child, Bezos dreamed of going into outer space, mainly with the crew of the Enterprise on Star Trek. He would participate in plays based on the TV series, taking on the roles of Spock, Captain Kirk, and even the computer. Upon his high school graduation, a time when most teenagers might fantasize about their first car or the senior prom, he laid out a visionary plan for the next century. He said he wanted to build space hotels, amusement parks, yachts, and colonies for 2 or 3 million people orbiting around the Earth. The whole idea is to preserve the Earth. The goal is to be able to evacuate humans. The planet will become a park, he wrote. As Bezos saw it, the polluting industrial output of the planet would eventually be moved into space. To put his money where his mouth is, as an adult, he founded the company Blue Origin to build the rockets of the future. The name of his rocket company refers to the planet Earth, which can be seen as a blue sphere from outer space. The aim is to open up space travel to paying customers. The vision for Blue is pretty simple, he says. We want to see millions of people living and working in space. That's going to take a long time, but I think it's worthwhile. In 2017, he announced a short-term plan for Blue Origin to set up a delivery system for the moon. He envisions a vast operation that, just as Amazon rapidly ships out a variety of products at the click of a button, could deliver machinery, building supplies, and goods and services to the moon. Once considered a lonely outpost in space, the moon will become a bustling industrial and commercial hub with permanent manned bases and manufacturing. This loose talk about cities on the moon might normally be dismissed as the ravings of an eccentric, but when it comes from one of the richest people of Earth, who has the ear of the President, Congress, and the editors of the Washington Post, one takes it all very seriously. To help pay for these ambitious projects, astronomers have looked into the physics and economics of mining the moon and noted at least 3 potential resources worth exploiting. In the 1990s, an unexpected discovery caught scientists by surprise: the presence of large quantities of ice in the southern hemisphere of the moon. There, in the shadows of large mountain ranges and craters, is a perpetual darkness that is below freezing. The origin of this ice is probably cometary impacts in the early history of the solar system. Comets are mainly made of ice, dust, and rock, so any comet that strikes the moon in one of these shadows might leave a deposit of water and ice. The water, in turn, can be turned into oxygen and hydrogen, which happen to be the principal components of rocket fuel. This could turn the moon into a cosmic gas station. The water could also be purified for drinking purposes or used to create small-scale agricultural farms. In fact, another group of Silicon Valley entrepreneurs has created a company called Moon Express to begin the process of mining ice from the moon. It is the first company ever to get permission from the government to begin this commercial enterprise. The preliminary target for Moon Express is, however, more modest. The company will begin by putting a lunar rover on the moon that will systematically search for the presence of ice deposits. The company has already raised enough money through private funding to proceed with this mission. With the financing in place, all systems are to go. Scientists have analyzed the moon rocks brought back by the Apollo astronauts and believe there may be another economically significant element on the moon. Rare earth elements are crucial for the electronics industry, but are mostly found in China. Rare earths are located everywhere in small quantities, but the Chinese rare earth industry makes up 97% of the world trade. China has roughly 30% of the world's reserves. A few years ago, an international trade war almost erupted when Chinese suppliers abruptly raised prices on these key elements, and the world suddenly realized that China had a near monopoly. It is estimated that the supply will begin to be depleted in the coming decades, making it urgent to find alternative sources. Rare earths have been found in moon rocks, so one day it may be cost-effective to extract them from the moon. Platinum is another important component for the electronics industry, and the presence of platinum-like materials, perhaps left over from ancient asteroid impacts, has also been detected on the moon. Finally, there is the possibility of finding helium-3, which is useful in fusion reactions. When hydrogen atoms are combined at extremely high temperatures found in these reactions, the hydrogen nuclei fuse, creating helium, plus large amounts of energy and heat. This excess energy is useful to power machines. However, this process also produces copious amounts of neutrons, which are dangerous. The advantage of the fusion process involving helium-3 is that it instead releases an excess proton, which can be handled more easily and deflected by electromagnetic fields. Fusion reactors are still highly experimental and so far none exist on Earth, but if they are successfully developed, helium-3 could be mined from the moon to supply fuel for the fusion reactors of the future. But this also raises a tricky point. Is it legal to mine the moon or to stake a claim there? In 1967, the Soviet Union, United States and many other nations signed the Outer Space Treaty, which banned nations from claiming ownership of celestial bodies like the moon. It banned nuclear weapons from Earth orbit and from being placed on the moon or elsewhere. The testing of these weapons is also prohibited. The Outer Space Treaty is the first and only one of its kind holding on to this day. However, the treaty said nothing about private ownership of land or the use of the moon for commercial purposes, probably because those who drafted it didn't believe private individuals would ever be able to reach the moon. but these matters must be addressed soon, especially now that the price of space travel is dropping and billionaires want to commercialize outer space. The Chinese have announced that they will put their astronauts on the moon by 2025. If they plant their flag, it will largely be symbolic, but what happens if some private developer stakes a claim to the moon after arriving on his or her private spaceship? Once these technical and political issues are settled, the next question is, what will it be likely to actually live on the moon? Our original astronauts only spent brief periods of time on the moon, usually a few days. To create the first manned outpost, future astronauts will have to spend extended time there. They will need to adjust to lunar conditions, which, as you can imagine, are quite different from Earth. One factor that limits how long our astronauts can stay on the moon is the availability of food, water and air, since they will exhaust the supplies that they carry with them within a matter of weeks. In the beginning, everything will have to be shipped from Earth. Unmanned lunar probes will have to be sent every few weeks to resupply the station. These shipments will become a lifeline for the astronauts, so any accident involving them could present an emergency. Once a moon base is constructed, even a temporary one of the first endeavors for the astronauts might be to create oxygen for breathing and for growing their own food. There are a number of chemical reactions that can produce oxygen, and the presence of water creates a readily supply, and this water can also be used in hydroponic gardens to grow crops. Fortunately, communication with the Earth will not pose much of a problem, since it only takes a little more than a second for a radio signal to reach Earth from the moon. Apart from a slight delay, astronauts will be able to use their cell phones and the internet like they do on Earth, so they could be in constant contact with their loved ones and receive the latest news. Initially, our astronauts will have to live inside the space capsule. When they venture out, the first order of business will be to unfurl large solar panels to harvest energy. Since one lunar day corresponds to one Earth month, any site on the moon has 2 weeks of daylight followed by 2 weeks of darkness, so they will need large banks of batteries to store the electrical energy harvested during the 2-week day for the use during the long night. Once on the moon, the astronauts might want to travel to the poles for several reasons. There are peaks in the polar regions where the sun never sets, so a solar farm with thousands of solar panels could create a steady supply of energy without interruption. The astronauts might also take advantage of the deposits of ice in the shadows of large mountain ranges and craters at the poles. It is estimated that 600 million metric tons of ice may be found in the northern polar region, in a layer that is several yards thick. Once mining operations begin, much of this ice could be harvested and purified for drinking purposes as well as for oxygen. It is also possible to mine the soil of the moon, which contains a surprising amount of oxygen. In fact, there are about 100 pounds of oxygen for every 1,000 pounds of lunar soil. The astronauts will have to adjust to the lower gravity on the moon. According to Newton's theory of gravity, the amount of gravity on any planet is related to its mass. The moon's gravity is about 1/6 of that of the Earth. This means that moving heavy machinery will be much easier on the moon, and the escape velocity is much lower, so rockets could both land and take off from the moon rather easily. In the future, a busy spaceport on the moon is a distinct possibility, but our astronauts will have to relearn simple movements such as walking. Apollo astronauts realized that walking on the moon was quite awkward. They found that the fastest way to maneuver was to hop. Because of the moon's lower gravity, you can hop much farther than taking a step, and it's easier to control your motion. Another issue to contend with is radiation. For missions lasting a few days, it does not pose a major problem, but if the astronauts spend months on the moon, they could accumulate enough exposure to seriously increase the risk of getting cancer. Simple medical problems could easily escalate into life-threatening situations on the moon. All of the astronauts will have to have first aid training, and a few of them will probably need to be medical doctors. If, for example, an astronaut has a heart attack or appendicitis on the moon, most likely the doctor will set up a teleconferencing session with a specialist on Earth who will perhaps perform surgery by remote control. Robots could be brought in to do various forms of microsurgery, guided by skillful hands back on Earth. The astronauts will need daily weather reports from astronomers monitoring solar activity. Instead of indicating upcoming thunderstorms, these weather reports will give warning of huge solar flares that send hot plumes of radiation into space. If there is a giant eruption on the Sun, the astronauts will be signaled to seek cover. Once the warning is given, astronauts will have several hours before a deadly rain of charged subatomic particles hit the base. One way to create shelter from radiation might be to dig an underground base within a lava tube on the Moon. These tubes, remnants of ancient volcanoes, can be huge, up to 1,000 feet across, and will provide adequate protection from radiation from the Sun and outer space. Once the astronauts have erected the temporary shelter, large shipments of machinery and supplies will have to be sent from the Earth to begin construction of the permanent Moon base. Shipping prefabricated materials and inflatable items could speed up this process. In building these underground bases, inevitably you will want the ability to manufacture and repair machine parts. Although large equipment such as bulldozers and cranes will have to be sent from the Earth, 3D printers could fabricate small plastic machine parts on site. Ideally, factories will be established to forge metal, but building a blast furnace is impossible since there is no air feed to feed the furnace. However, experiments have shown that lunar soil, when heated by microwaves, can be melted and fused to make rock-hard ceramic bricks, which could be the basic building blocks for the entire Moon base. In principle, all of the infrastructure could be made of this material, which can be harvested directly from the soil. Lastly, there has to be a source of entertainment for the astronauts, a way to blow off steam and relax. When Apollo 14 landed on the Moon in 1971, NASA officials did not know the commander, Alan Shepard, had secretly smuggled a 6-iron golf club into the space capsule. They were surprised when he proceeded to take out the club and hit a golf ball 200 yards on the lunar surface. This was the first and only time someone engaged in a sports activity on another celestial body. A replica of the golf club is now in the Smithsonian National Air and Space Museum in Washington. Lunar sports will pose a particular challenge due to the lack of air and low gravity, but they will also give rise to some remarkable feats. On Apollo 15, 16 and 17, our astronauts rode the lunar roving vehicles over the dusty surface, each traveling between 17 and 22 miles. Not only was this a valuable scientific mission, it was also a thrilling expedition as they looked out at majestic craters and mountain ranges, knowing that they were the first people ever to see these stunning sights. In the future, riding dune buggies will not only accelerate the survey of the lunar surface, the installation of solar panels, and the construction of the first lunar station. It will serve as a type of recreation. It may perhaps even make possible the first races on the Moon. Lunar tourism and exploration could become popular recreational activities as people discover the wonders of an alien landscape. Given the low gravity, hikers will be able to trek over long distances without tiring. Mountain climbers will be able to rappel down steep mountain sides with little effort, and from the top of craters and mountain ranges, they will have an unprecedented panorama of the lunar landscape, literally untouched for billions of years. Spelunker who love to explore caves will be excited to investigate the network of gigantic lava tubes crisscrossing the Moon. On the Earth, caves were carved out by underground rivers and contain evidence of ancient water flows in the form of stalactites and stalagmites, but on the Moon there are no appreciable deposits of liquid water. The Moon's caves were instead carved out of the rock by molten lava. They will definitely look different from the caves that we have on Earth. Once mining operations successfully exploit the resources found on the surface of the Moon, we will inevitably turn our eye to the riches that may lie deep within it. Uncovering them will change the economic landscape as the accidental unexpected discovery of oil on Earth did. But what is the interior of the Moon like? To answer this, we have to consider the question: where did the Moon come from? The origin of the Moon has fascinated humanity for millennia because the Moon rules the night. It has often been associated with darkness or madness. The word lunatic comes from luna, the Latin word for moon. Ancient mariners were fascinated by the connection between the Moon, the tides and the Sun, and correctly ascertained that there is a close correlation between all three. The ancients noticed another curious fact: you only see one side of the Moon. Think of all the times you have looked at the Moon and you realize you're always seeing the same face. It was Isaac Newton who finally put all the puzzle pieces together. He calculated that the tides are caused by the gravitational pull of the moon and the sun on the Earth's oceans. His theory indicated that the Earth creates tidal effects on the moon as well. Since the moon is made of rock and has no oceans, it is actually being squeezed by the Earth, and this force causes it to bulge slightly. At one time, it tumbled in its orbit around the Earth. Eventually, this tumbling slowed down until the spinning of the moon was locked to the Earth, so that one side of it always faced us. This is called tidal locking, and it happens throughout the solar system, including for moons of Jupiter and Saturn. Using Newton's laws, you can also determine that tidal forces are causing the motion to slowly spiral away from the Earth. Its orbital radius increases by about 1.6 inches per year. This small effect can be measured by shooting laser beams to the moon. Our astronauts left a mirror behind to help with this experiment, and then calculating the time it takes for the beams to bounce back to Earth. The round trip takes only about 2 seconds, but this number is gradually increasing. If the moon is spiraling away, then by running the videotape backward, we can estimate its past orbit. A quick calculation shows that the moon separated from the Earth billions of years ago, and modern evidence indicates that 4.5 billion years ago, not long after the Earth was formed, there was a cosmic impact between the Earth and a large asteroid of some sort. This asteroid, which we call Theia, was about the size of Mars. Computer simulations have given us dramatic insight into these explosions, which gouged out a huge chunk of the Earth and propelled it into space. But because the impact was more of a glancing blow than a direct strike, it didn't take much of the interior iron core of the Earth. As a result, the moon, while it does contain some iron, has no significant magnetic field because it lacks a molten iron core. After the collision, the Earth resembled a Pac-Man with a huge pie-shaped piece carved out, but because of the attractive nature of gravity, eventually both the moon and the Earth condensed into spheres again. Evidence of the impact theory was provided by the astronauts who brought 842 pounds of rock back from their historic trip to the moon. Astronomers discovered that the moon and the Earth are made of almost the same chemicals, including silicon, oxygen and iron. By contrast, random analysis of rocks from the asteroid belt shows that their composition is quite different from that of Earth. I had my own encounter with moon rocks when I was a graduate student in theoretical physics at the Berkeley Radiation Laboratory. I had a chance to view one under a powerful microscope. I was surprised by what I saw. There were tiny craters caused by micrometeors that had impacted the moon billions of years ago. Then looking more closely, I saw craters inside these craters, and even smaller craters inside those. This chain of craters inside craters would be impossible in Earth rock, since these micrometeors would have vaporized while going through the atmosphere. But they could hit the lunar surface because the moon has no atmosphere. This also means that micrometeors could be a problem for astronauts in the moon. Since the composition of the moon is similar to that of Earth, the truth may be that mining the interior of the moon is only useful if you're building cities on the moon. It is probably too expensive to bring moon rock back to Earth if it only offers what we already have, but lunar material could be immensely valuable for creating a local infrastructure of buildings, roads and highways on the moon. What will happen if you took off your spacesuit on the moon? Without air, you will suffocate, but there is something even more disturbing. Your blood will boil. At sea level, water boils at 212 degrees Fahrenheit or 100 degrees Celsius. The boiling point of water drops as atmosphere pressure drops. As a child, I had a vivid demonstration of this principle one day while camping in the mountains. We were frying eggs in a pan over a fire. The eggs, sizzling away in the pan, looked delicious, but when I ate them, I almost threw up. They tasted awful. Then it was pointed out to me that as you climb up a mountain, the atmospheric pressure begins to drop and the boiling point of water decreases. Although the eggs bubbled and appeared to be fried, they were never completely cooked. The bubbling egg wasn't so hot at all. I had another encounter with this fact when celebrating Christmas as a child. At our house, we had old-fashioned Christmas lights consisting of thin tubes of water placed vertically on top of each electrical fixture. When we turned them on, they were gorgeous. The brightly colored water in the tubes began to boil in various colors. Then I did something foolish. I grabbed the tubes of boiling water with my bare fingers. I immediately expected to feel the intense heat of boiling water, but I felt nothing. Years later I realized what had happened. Inside the tube was a partial vacuum. As a consequence, the boiling point of water dropped, so even the heat of a small electrical fixture could make the liquid boil. But the boiling water wasn't hot. Our astronauts will encounter the same physics if they ever have a leak in their spacesuits in space or on the moon. As their air leaves the suit, the pressure inside drops and the boiling point of water also drops. Eventually the blood in the astronaut's body will begin to boil. Sitting in our chair here on Earth, we forget that we have almost 15 pounds of air pressure pushing down on every square inch of our skin because there is a huge column of air sitting right above us. Why aren't we crushed? Because we have 15 pounds of pressure pushing out from inside our body. There is a balance. But if we go to the moon, those 15 pounds of pressure beating down on us from the atmosphere disappear. Then we only have the 15 pounds of pressure pushing outward. In other words, taking off your spacesuit on the moon could be a very unpleasant experience and is best to keep on at all times. What might a permanent moon base look like? Unfortunately, NASA has not issued any formal blueprints, so all we have are the imaginations of science fiction authors and Hollywood scriptwriters as rough guides. But once a lunar base is constructed, we will endeavor to make it totally self-sustaining. Such a system will vastly lower costs. But it will require a great deal of infrastructure, factories to create buildings, large greenhouses for food, chemical plants to create oxygen, and huge solar banks for energy. To pay for all of this, one will need a source of income. Since the moon is largely made of the same material as Earth, we may need to look beyond it for a revenue system. That is why Silicon Valley entrepreneurs have already set their sights on the asteroids. There are millions of asteroids in space, and they may be home to untold riches.